All right, last thing with systems of equations, I'm going to go over some special cases, and then we're going to do this little activity right here, determine which is the best method to solve. All right, so pause it, and y'all choose, like elimination, substitution, or graphing. Okay, whichever one you think is the best, and choose one for each. Okay, then unpause the video and come back and see how you did. All right, so like I said before, the best method is the method that you're going to get right. So if like graphing and substitution don't compute in your mind and you can do elimination every single time, great. It may not be the most efficient way, but it will work on every problem. Okay, so the best method is one you're going to get right. But if you want to do things the most efficient way possible and be able to use all three methods, which is going to be beneficial to you later on when you do other types of systems of equations, which we will be doing soon, then you want to be able to use all three. So this first one, see how the x's are stacked up and the y's are stacked up and the constants? Okay, I would say the best one to use on this one is elimination. Okay, all we'd have to do is multiply the top one by 2, and that would give us a positive 16, and it would cancel, and then we're on our way. Okay, the second one, I have one that's in standard and one that's in slope-intercept. Okay, so I would be able to take this and substitute it in for y pretty easily, and then figure out what x is, and then we're off to the races. So I'd say this one is best for substitution. All right, last one, they're both in y equals form. Okay, that's super easy to graph. You plot your y-intercept, you do your rise over run, figure out where they intersect. So I would use graphing on this one. Now you're going to come across some problems that aren't on any of these. They're just all jumbled up and weird looking. Okay, on those you're just going to have to go with your gut. What do you think the best method for you is, and go with it. Okay, make a decision and then do that method. Okay, don't second guess. Don't try to combine methods. That doesn't work. Choose one method and go with it. Okay, and just look at the problem and see if you think there's a way that it's going to be the easiest for you. All right, some special cases. Okay, so I have a couple. We got this one in y equals form, and if we were to just add 4 over here, we get this one in y equals form as well. So that'd be y equals 3x plus 4. And then this one is y equals 3x plus 4. So one of our special cases is, what if they're the same line? Okay, if I were using the graphing method, okay, I would plot positive 4, and then I'd do rise over run. I'm going to do negative 3 over negative 1. So I'm going to go down here like this. All right, and that would be the line. And then I'd graph it again, and it'd be the exact same line right on top of this one. So if I'm looking for points of intersection, well, this is intersecting everywhere. The whole thing's intersecting. It's intersecting here and here. They're right on top of each other. So the way that we say this is there are infinitely many solutions, because it's intersecting the whole time and it keeps on going forever in both directions. So infinitely many solutions is how you describe that when it's the same line. Okay, over here, if we add 2, we'll get this one in y equals form, and we get y equals 5x plus 2. So these have the same slope, but they have different y-intercepts. So they're not the same line. These are parallel lines. All right, and what do we know about parallel lines? They never intersect. Well, if our entire solution is based on 2 lines intersecting and these never intersect, that must mean these are no solution. All right, just so you know, there's a symbol for that. If you draw a 0 with a slash through it like this, that means no solution. So if you ever see that on an answer choice, or if you just don't feel like writing out no solution, you can just put a 0 with a slash through it. It means the same thing. All right, what do these special cases look like with the other methods? So that was kind of the graphing method. If you were to graph these, you would see that. So what does it look like if we're doing elimination? Okay, so let's say I'm doing elimination on this one. Okay, I need to multiply this by negative 2, because negative 2 times 2 is negative 4x. Negative 2 times 3 is negative 6y. And negative 2 times negative 6 is negative 12. And if we add all this together, that's going to cancel, that's going to cancel, that's going to cancel. So there's 0 left over here, and there's 0 left over here. 0 equals 0. Is this true? Yes. If it's true, That's the infinite. These were the exact same line. If we were to get them, let's try to spell this right, infinitely many solutions. Okay, if we were to have graphed those, they would have same slope, same y-intercept. All right, let's try another one over here. So this one, I need to multiply by -2, because -2 times 1 is -2x, which will cancel with that. -2 times -2 is positive 4y, and -2 times 4 is -8. So those will cancel. Those will cancel. That's 0. 12 minus 8 is 4. 0 does not equal 4. That's false. And that's the one that's no solution. Alright, what does it look like for substitution? Okay, so these are already in the perfect form, so we plug that in there. So that'll be 2x plus -2x plus 4 equals 4. Okay, we don't really need those parentheses because there's no number in front to distribute. So I'm just going to get rid of the parentheses. And 2 plus -2, those cancel. So that leaves me with 4 equals 4. So same deal as elimination. If it's true, it's infinitely many solutions. Alright, and if we do this one over here, so we're going to plug in -x plus 4. So that's 3x plus 3 times -x plus 4 equals 9. I need to distribute the 3, so that's going to be 3x. That's going to end up being a -3x, and that's going to be a positive 12 equals 9. 3x and the 3x cancel. You get 12 equals 9. That is false. And that's no solution.